Hey everyone, welcome once more to our YouTube channel. So today we want to quickly look at vector analysis for engineering, and here is a quick outline of what we're going to be looking at in this video. So first thing, we're going to look at vector addition and subtraction, and then we'll look at applications, and then of course we'll look at vector multiplication, and then we'll look at sample engineering exam problems. The sample engineering exam problems would range from Polytechnique Yaounde, Polytechnique Bamenda, College of Technology, and then we'll have a few questions from the Indian Engineering Entrance Examination, which is of course the JEE Advanced. So let's dive in. Okay, so the first aspect here is of course addition of vectors, and we have that, well, the resultant or sum of a number of similar vectors is that single vector which has the same effect as all the individual vectors taken together, right? Vector addition is carried in the following two ways. Well, I've actually just outlined just one way here, and then I've done calculations with the other way. So you're just going to get the other way when I'm doing calculations, because I'll explain when I'm solving problems on vectors. If two vectors are represented in magnitude and direction by two adjacent sides of a parallelogram, then their resultant can be represented in magnitude and direction by the diagonal of the parallelogram passing through a common point. Well, of course, this is very important that the resultant vector goes through a common point that is common to both the individual vectors that are present in that particular mechanical system, right? And this is one of the reasons why, well, it's very important for you to be able to find the line of intersection of two vectors, and then to find the position vector of the point of intersection, and then from there to be able to diagnose the resultant of those two vectors, really. So you just need a point on the line, which is basically that point of intersection, and then the direction of the line, right? Good. So we can go ahead and get examples. So the resultant vector between u and v, given that the angle between u and v is theta, is, well, the resultant force would simply be the square root of u squared plus v squared plus 2uv cos theta. Now, if r makes alpha with u, then tan alpha equals v sine theta over u plus v cos theta. Okay, so I'm basically using this diagram to show that the resultant of these two vectors v and u, which we have said is also known as the sum of these two vectors u plus v, we can calculate that resultant like this, but there's a proof, and let's prove that. Now, so the proof, I'm just going to draw a diagram like this. So we get our u, right? Then we get our v, and then we get the resultant. Now notice that we have u like that. And then so the head of u, this is the head of this vector, follows up with the tail of v, right? So they're adding up right there. So whenever you see vectors, the head following the tail of another vector, it means that they're basically just adding, right? And then you see that the two vectors u and v, they add up like that, head to tail, and then they give you the resultant because you now get head here. So this means that these two vectors, they add up, and then this guy is their resultant. Sorry that this answer is not annotated here. All right, so let's just look at what's happening. By the cosine rule, right, again, notice that the angle alpha is the angle between vector u and r, right, the resultant. And why are we calling it the angle between these two vectors? Well, because they are both leaving this node. If I come to this particular node, notice that r is leaving, right? That's the head of the vector right there, leaving. The head of this other vector u is also leaving. So you notice that the two vectors are leaving this node. So that means that the angle subtended by these two vectors at this particular point would actually be the angle between the two vectors. Are we together? Now, but if you get over here, the angle between these two vectors is not pi minus theta. This is not the angle between v and u. Why? Because u is actually entering this node while v is leaving that node. So because the two vectors don't have the same sense around this node, then this angle cannot be the angle between the two vectors. Now notice that I've come over here and I've indicated that this has to be the angle between them, because if I continue the line of action of this vector, notice that this guy is still leaving this node. This is the node now, but it's leaving out there, right? And then this guy is also leaving this node. So the angle that comes from this guy leaving all the way to this other guy who is leaving, that is now the angle between the two vectors, and I've called that theta. So if that angle is theta, then you notice that this other angle here would be pi minus theta, right? Because it's a straight line like this. Perfect. So if this is pi minus theta, this is alpha, then this has to be pi minus alpha. So that when I sum up all these angles, they give me 180, right? Good. So you notice that r squared will be equal to v squared according to cosine rule, right? R squared here will be v squared plus u squared minus 2uv cosine of the angle opposite to this arrow, which is pi minus theta. But what is cosine of pi minus theta? Of course, it is negative cos theta. And so the negative would affect this negative, and we'll have plus 2uv cos theta right there, right? And so that will be the resultant of these two vectors. So that is a proof right there that if I get two vectors u and v, where the angle between them is theta, then the result of those two vectors basically be u squared plus v squared plus 2uv cos theta, square root of that. Now, if we want to get the angle that this vector u makes with the resultant r, really, this is just vector analysis. They could give you any other two vectors and they ask you to get the angle between them. So I'm just doing this for vector analysis, okay? For you to get comfortable with doing vectors. So by the sine rule, of course, we're going to get over here v over sine alpha, right? Should be equal to u over the sine of the angle opposite to it. So sine of the angle opposite to it is theta minus alpha. So if we simplify this, we'll get sine theta minus alpha over sine alpha to be equals to u over v, right? So you're just interchanging v and sine theta minus alpha here. So we get over here, what is sine theta minus alpha? It is sine theta cos alpha minus sine alpha cos theta, right? Compound angles right there. And then we can distribute this sine alpha to each one of these terms. And so we are going to get, we distribute this guy, we're going to get sine theta, because sine alpha here divides cos alpha, it gives us 1 over tan alpha, right? Or cot alpha, which is 1 over tan alpha. So you have sine theta over tan alpha there. Minus sine alpha goes over sine alpha, we're left with cos theta there, right? So we have u over v. And so you notice that we can get sine theta over tan alpha on one side and then carry our cos theta the other way. And so you have u over v plus cos theta. Now our tan alpha, very quickly, right? We can look for LCM here, and our LCM means that we'll get u plus v cos theta over v. So we reciprocate both sides, and our tan alpha would simply be v over u plus v cos theta. Of course, we can multiply by sine theta, so we get this. So I've done some quick simplification here. I have not followed the steps, right? I hope you followed. So yes, guys, this is how you prove that the resultant of two vectors is this, and that the angle one of those vectors makes with the resultant can be found like this. All right, let's move on to more important things. So we can also explore vector subtraction, okay? So to subtract b from a, the direction of b is reversed and then added vectorially to a. So a minus b simply means that a plus negative b, really, all right? So you're finding the resultant of what? Of a and negative b. I really wish that you rather take that last statement I just made. So a minus b is basically finding the resultant of a and negative b. All right, now, so if you look at this, this is our b right here. Our negative b goes the opposite way, right? This is our a. Now, if this is a, by the parallelogram rule, so this is still our a, we can represent a here like that. But before that, if you want to get what a minus b is going to be, watch. We can actually go over like this. So this is our b, right? This is our b going up. Okay, but now let's start from this node. This is our a going up. So if I go a, now notice that this arrow is opposite, right? So head is meeting a head. So this must be a negative vector here. So I'll go a minus this vector. Notice that by the parallelogram rule, this is b. This has to be b too. So we'll have a minus b equals this. And what is that? It is basically a minus b right here. Right, so you have a plus negative b, which is this, gives you this vector, which is the resultant. You can also get down here, if this is b, this will be negative b down here, right? So they share the same line of action, but different senses. B goes up, negative b goes down. So our a, this is our a going up, so we have negative b plus this a gives us this resultant, which is basically a minus b. Boom. So that's how you really figure out what is happening, right? A minus b is basically the resultant vector between a and negative b. So we can, that has some very cool applications, really. What we just talked about has some really cool applications. One of the applications is, of course, relative velocity, which is a very simple thing. In theory, it's really simple, right? Like I'm talking about it right now. VAB is basically VA minus VB, right? Which is the relative velocity between A and B. And then the relative velocity between B and A is VBA, which is VB minus VA. Simple, right? until you begin to see concours problems on this. So stick around to check out how concours problems look like with relative velocity. We can also talk about change in velocity. Okay, it's an application of vector subtraction. So if a body is initially moving with a velocity vi in a certain interval, its velocity changes to vf, then the change in velocity dv is given by well, v final minus v initial. It really looks like there's no worries here, right? Perfect. Until you begin to add directions and begin to twitch some things. All right, let me not hurry up. Would see them in concours problems. You can also get to talk about vector multiplication, right? So vectors can be multiplied in two different ways, scalar or dot product. So again, a dot b, which is mag a mag b equals theta. I've not talked about the cross product, right? Which is basically the magnitude of the cross product is, of course, magnitude of uh, ab sine theta instead. But I've not talked about that because it does not have so many applications in, of course, this part of vector when you are taking the entrance exam into concours. So I've mentioned this because you can calculate the work done by moving a particle from one position vector to another by simply doing this work. So you need to find the displacement vector, you dot that to the force vector. All right, so this is really why I just needed to show this, and then we can go on to checking out our examples finally. So the first example here is COT, a problem in College of Technology 2020 Buea. A man entered a cave and walked 150 meters north. He then made a sharp turn 150 degrees to the west and walked 85 meters straight ahead. How far is the man from where he entered the cave? Okay, so we're just going to quickly do our work here. So this is our man here, gets into the cave here, walks up 150 meters, makes 150 degrees turn to the west, right? So 150 degrees means that, hey, if I go all the way 150, I'm simply left with what? 30 degrees to get back down here to where I originally started. So it means that the path that he's now traversing is basically 30 degrees from this original path that he was on, right? And so that's why I've left out the 150 there. So you notice this is 30 degrees, and then he has to travel 85 meters on this path. And so this final path will just be x, right? So how far is he? We are just calculating this x from the original position. So get x squared there, you're applying cosine rule, right? Like we've seen. So x squared will be 85 squared plus 150 squared minus 2 times this times cosine of the angle opposite to this guy, which is 30 degrees. And x squared is that. And so we can get x to be 1.4 times 10 to the power 2 meters. And if you had to write this in one significant figure, that would be 100 meters. So that is C right there. The next problem is still another problem on vectors from College of Technology COT Buea 2020. So the arrows shown below represent all the force vectors that are applied to a single point. Which of the following could not be true of the point? Okay, so let's just analyze what we're analyzing. So we get that now I want to use this f and this 3f, root 3f as our references, okay? Notice that this f and this root 3f are perpendicular to one another, so I'm going to use them as references. So I'm going to resolve this 2f along this reference line, along these two reference lines, okay? So if this is 2f and this is 150 degrees, right? Remember that if this is my reference line, so I'm going to just draw a horizontal line along. So this is my horizontal line. So an angle from here all the way here to is 150. So it's 180, sorry. So if this is already 150, so this has to be 30 degrees here, right? And if this is 30 degrees, remember that this guy and this guy are perpendicular. So this guy has to be 60 degrees here. So I'm going to resolve 2f cos 60 degrees. So this is a component of this guy, this 2f along, right? And it is adjacent to this angle, so it's basically 2f cos 60. And then the guy who is opposite to this angle should be 2f sine 60, and that's what you have. But notice that 2f sine 60 is root 3 on 2, which gives us f root 3f. And you notice that this guy 2 cos 60 is half, and 2f times half gives us f. And so you realize that the resultant force in the x and in the y direction is 0, because you have f minus f, and then you have root 3f minus root 3f. And so the resultant force on this particular particle is 0 newtons. The resultant force being 0 newtons means that, hey, the point is So this guy is a wrong statement, right? Because look at not could not be true of the point. So we're looking for the statement that is wrong here, and that the statement is, of course, the point is accelerating at a constant rate. There's no way you can accelerate if the resulting force on you is zero, right? You'll be disobeying Newton's second law. And so that's why our C is our right answer in this case, because it is the only point that is not true. But look at A. A says the point is moving at a constant velocity. It is possible, right? So whenever the resultant force acting on a particle is zero, it means that the particle can either be in static equilibrium or in dynamic equilibrium. If you're in dynamic equilibrium, you're moving with constant velocity. If you're in static equilibrium, you are not moving at all. The point is not moving. So these two are very possible. The point is not accelerating. Correct. So this is correct. So if you're not moving, you're also not accelerating, right? Or you're moving with a constant speed, you're not accelerating. Perfect. So you see how C is the odd guy out here. Okay. Next problem is a Pew vector problem. It says two vectors A and B have magnitudes of 10 units, and the angle between them is this. Find the magnitude of this and this, and then the second question says that. So just pause the video right here and attempt the problem, okay, guys? Just attempt the problem right here. So I'm going to solve the problem. Two vectors A and B have equal magnitudes and that. So find the magnitude of A plus B. Well, A plus B is basically the sum of these two vectors now, whose angle between them is 60. So if I'm summing two vectors whose angle between them is 60 degrees, then I'm just looking for the result of those two vectors, right? And we know what resultant is A squared plus B squared plus 2AB cos theta. So our A plus B there is that cos 60 degrees. And so notice that that gives us 10 root 3 newtons. We can go over and then look for A minus B, but the trick here is that A minus B is a resultant vector between the two vectors A and negative B, right? And if A and B, the angle between them is 60 degrees, then what would be the angle between A and negative B? It will simply be 180 minus 60 degrees, which gives us 120 degrees, okay? Take note of that. If the angle between two vectors A and B is 60 degrees, or is theta, then the angle between A and negative B would be 180 minus theta, or the angle between B and negative A would still be 180 minus theta, okay? Perfect. So when you put that in, and you notice that our A minus B would basically be 10 newtons right here. You solve the problem within the twinkle of an eye. There are other ways you can solve it by drawing a diagram and then representing what A minus B is and where A is. But again, if you really know this trick right here, then you're good to go without even drawing the diagram. All right. So the second part of the problem says two forces have equal magnitudes and the resultant also has the same magnitude. Find the angle between the forces. Okay, so we have the resultant is A squared plus B squared plus 2AB cos theta, and well, the resultant there is the same as the individual vectors, which is the same as okay, yeah, basically the same as the individual vectors. So you have arrow squared here, so A, in place of A and B, I'll put arrow and arrow, right? Arrow right there, and then you have theta, the angle between them. So I factor out arrow squared here, that would mean that I'm left with 2 here plus 2 cos theta. Well, r squared can go with this r squared, and then we can divide all 2 by 2, so we have half here, and then we have 1 plus cos theta, right? And so our cos theta is negative half, which means that our theta is 120 degrees. Right there, that's the solution, and that is the result. Another interesting problem would be such problems, even though this diagram like that was not in the concours problem, this one was not there. I'm the one who did this on Word, then I had to just snap it and then post it, just paste it here so that it's easier for the students. So two cables are attached to an eye. The direction of the forces F1 and F2 in the cables are given by alpha and beta. Determine the magnitude of the force H exerted through the wall onto the eye. Okay, so this will have indicated that H will be acting. So I hope that you just take out your time right now and attempt the problem, right? So how are you attempting the problem? Now notice that I've indicated the directions of these two vectors. I've really drawn a polygon of vectors really. And you've noticed that our H or our F1 is going downwards like this. So this is our F1. Our F2 is going upwards. So you get our F2 right there. our H is slanting downwards, and you get H slanting downwards like that. So you've gotten a polygon of horses, really, which is in this case a triangle of horses. Now, the next thing you have to do is indicate the angles between each one of these horses. It's a very complicated process. No, not really overly complicated, but just you need to take your time. So if this is beta, this is alpha, what will be the angle between F1 and F2? It will simply be 180 minus alpha minus beta, right? That will be the angle between these two vectors. Now, but notice that between F1 and F2 here, this is F2, this is F1, this guy is entering this node, this guy is leaving this node. So this angle here is not the angle between F1 and F2. So you know the angle between F1 and F2, but that angle is not this angle here, right? Because in this polygon, of course, these two guys are following up each other. Okay, good. But here they are leaving out. So what you have to do is just really realize that I can now get the angle here by taking 180 minus the angle between the two vectors. And when you do that, you'll now notice that the angle, this angle right here, will basically be alpha plus beta, right? I hope you got what I said. Okay, this is alpha plus beta here. So the next thing would be to determine what this guy is, the angle between F1 and H. So this is our F1 here, this is our H here. But it's easy to get, right? Because this, our H here is alpha. Well, no, this first angle here is alpha. So to get this other angle, I will simply get 90 minus gamma, right here. So I get alpha 90 minus gamma right here. That will be the angle between H and F1. But now notice that H is entering, F1 is leaving, and this is not the angle between those two vectors. So what do I have to do? I have to take 180 minus this thing I've just gotten here. And if you take 180 minus that, you get this result. You take your time, practice what I'm saying. Each thing I say, just write it down, and then you see how it makes sense at the end of the day. All right, so I'm just going to go ahead and then solve, right? We're going to apply, of course, our famous cosine rule. So if we get h squared here, it's basically going to be f1 squared, f2 squared minus 2 f1, f2 cosine of the angle opposite, which is alpha plus beta. And that's it. You've already gotten h because the examiner has given you f1, f2, and then cosine alpha plus beta, right? So you've solved the problem right here. But the next thing is you need to be able to define where forces act. So like maybe gamma from the horizontal, right? So we need to look for gamma. So how do you do that? Of course, you use sine rule, right? So you get over here, you get f2 over sine of this angle, which is opposite, right? Equals f1 over sine of this angle, which is opposite. Of course, 90 minus all of this simply means that we have cos alpha plus beta right there, right? Because 90 minus this is complementary to what? Alpha plus beta. And then you have sine of gamma minus alpha plus 90, which is the same as cosine of gamma minus alpha. And so you realize that I can basically make cos of this the subject, right? How do I make that? I'll get f2 over f1 multiplied by cos alpha plus beta, which is this, right? And then I get cos inverse of that, add alpha to 8. Really have to skip some steps here, but I guess you can follow up what I've just done here, right? And so this is the result. So this is the force that of course, the cables will exert on the eye, and they would exert that force at an angle of gamma from the horizontal. So the final problems I'm going to solve here are these two tiny problems. So they are going to, so just pause right here and attempt the problem yourself. Oh geez, I didn't animate this diagram. It's okay. So I've just indicated that, all right, so you get VI, so you're traveling north, right? So because the guy says a car traveling due north at 20 kilometers per hour turns east. So you're turning east. So initially VI, and then you turn east VF, right? And so the resultant I've just indicated right here, because you are using vectors to analyze this. Find a change in velocity and the magnitude. So find a change in velocity. Remember we talked about change in velocity earlier. So change in velocity is basically V final minus V initial, right? And so you notice that our V final minus V initial would simply mean that according to our vector analysis would be the resultant vector between VF and negative VF, right? And since the angle between these two vectors is 90, because if I continue, this guy is going up, this guy is also leaving this node, and that will be 90 degrees here. This is also 90 degrees. Perfect. So you notice that the angle between those two vectors would now be pi minus 90, which is again still 90 really. So we get that, and so you notice that we're going to get 20 squared plus 20 squared, which is basically, now notice that cos 90 here is 0, that's why you are seeing me put 0 here, which is basically 20.2 kilometers per hour, and that's the change in velocity there, right? When our students first saw this, they were like, oh, so the change in velocity will just be 0. No! In vector analysis, you don't calculate change in velocities like that. The change in velocity is basically an application of finding how to subtract two vectors, really. Okay, so if the angle here was not 90, it would have been even more interesting, right? Yeah, I think you can notice that. Good. So if you had to move maybe due east at a certain angle, at a certain bearing that is different from bearing that is just directly eastward, that would have made it very much more interesting. So you have that we A is the V dt here. That's our acceleration, right? Change in velocity over time. So our acceleration is, what's our change in velocity? Is 20 root 2 divided by the time, which is 10 divided by 3,600. So of course 10 here is 10 seconds. So you have to convert that to hours since our change in velocity is kilometers per hour. So you have acceleration there to be 7,200 root 2 meters per second squared. Oh no, kilometers per hour squared, right? Because I converted this guy to kilometer to hours, sorry. So that is supposed to be kilometers per hour squared. Oh Jesus, that's bad. This is kilometers per hour squared, guys. All right, so our theta then will just be tan inverse of V initial over V final, which is 45 degrees from the east, right? So this angle like that will be tan inverse of this over this, which is 45 degrees. That's from the east. Good. The last problem, which I suppose you have attempted, is right with this diagram here. A boatman can row with a speed of 10 kilometers per hour in still water. So that's absolute velocity right there. If the river flows at 5 kilometers per hour, in which direction should the boatman row in order to reach a point on the other bank directly opposite to the point from where he started in the shortest possible time? If the width of the river is 1 kilometer, find the time taken to cross the river. So want to reach in the shortest possible time, I want to reach on the opposite side directly from where we started. So it means that the river is flowing at this velocity. This guy has to bank the boat at a certain angle, theta, from this horizontal line, such that the resultant of his own velocity and that of the speed of the river would basically give you a resultant velocity that lies along this path. Okay, and so it would enable the boat to travel on a straight line like this. So of course we are going to do the basic mathematics here. If you really understand the problem, then you have to represent it like this. Then you just go ahead and then you calculate theta and then VR. So VR squared, of course, will be 10 squared minus 5 squared, because we can just apply Pythagoras here, right? So VR squared will just be 75, which will now give us VR to be 5 root 3 kilometers per hour. Now, our time is basically the distance covered divided by VR divided by velocity now, and the width of this river. Remember that the width of this river is 1 kilometer, according to the examiner. And so our time here would basically be 1 kilometer divided by VR, and our VR is this. So you have that our time is root 3 over 15 hours, and that gives you 6.9 minutes in minutes, right? So you notice that these engineering exams are not very strange. They just require you to be able to use your high school knowledge, the things you've learned from high school, and be able to think deeper, be able to tackle problems that are not very familiar to your high school coursework, right? And boom, you can handle it, guys. And so that's the end of what I'm going to solve today. But before I go, I'm going to give you guys some assignments. So right here, you have these problems as assignments. Just go ahead and attempt them. All right. If you have the solutions, drop them in the comment section. If you don't, shoot me a message. This is my number right here. Shoot me a message on WhatsApp. We'll keep in touch. Also try this problem. Oh boy, try getting alpha 1 and alpha 2. Really do. So